Well, hello, as the late, great comedy actor Leslie Phillips would say, who recently died at the age of 98. And a peculiar British thing his comedies were. So, enough of that. Today I thought I'd do a video on this bench multimeter, which is a VICI, I don't know how you pronounce it, but that's near enough, VC 8145 dual display multimeter. So let's turn it on. Now that is interesting, because when I first got it, you had to press the light button to make it come on, and the display is fairly poor without having that turned on. Anyway, it's now been modified, but that's another story. So it always comes on as soon as you turn the main power switch on. But back to this history of this meter. I bought this about 6-7 years ago probably. I think it was about £100, which is a fairly cheap price for a bench multimeter, I guess. But never really liked it, took an instant dislike to it. And it's been sitting languishing in a cupboard for quite a few years. I suppose I could have resold it on eBay, but what would I have got for it? Not a lot. But in the meantime, I bought a HP 34401A, I think is that the model, which is a far superior meter for accuracy and many other things which I can't think of at the moment. And so this meter has been in that cupboard for years, but now I thought I might as well drag it out, as I've got another workbench here. Why not use it? So the other thing I didn't like about this thing, apart from the light not coming on when you turn it on, is this silly tilting valve. It is absolutely horrendous. You have to fiddle around with it for ages till you get it to the right place. But once you've done that, it's still not right now. God, it's awful. I went on the last setting. Right, I think I got it. And now, I think it's right. But once that's been set once, it's not an issue really. What to say about this meter? It's got several nice functions about it. It's got an 80,000 count display, whereas the HP, I think, is, don't quote me, 20,000 counts. Might be something like that anyway. But in other words, you can read up to 79999999999 or something like that, and you've still got the resolution. But as soon as you go over the 1 over the 8, you will reduce your resolution by 1 digit. So that's a nice function. And it's got RS-232 on it, as it proudly says up there. I never use RS-232, wouldn't know what to do with it. So what other functions does it do? Well, we're in DC mode at the moment, and it has actually 2 displays on it, the main display and a smaller one. So if I do the select button, I now get a secondary display, and you can select what you have in that display. And at the moment it's presumably picking up mains hum off the workbench. Well, when it's in that secondary display, I notice the update rate is a lot slower, and to change that to a different display, I can press second view, and now I have AC in that in that secondary display, although that looks identical to the DC, so that doesn't make sense to me. That makes no sense at all. Let's go back to press that again. Or AC, try AC, then go back to that one again. So, select, and second view. So that should read AC volts. And that should still read, DC volts, but that doesn't. Let's try a battery on it, see what it does. Okay. Although it takes its time to settle, that would appear to be working. Measuring the DC on the main display and a very small amount of AC. Well, I don't know where it's picking that up from, but that would be a useful function to have that if you were... I don't like the fact that it's not going back to zero. Surely that's the DC. Let's try select again. No, I should have pressed second view. No, that mystifies me a bit, because that should be indicating nothing on DC. But whatever. And that particular function would be useful if you were testing on the input of a power supply, the rectified output. And on the smoothing capacitors you could read the DC, and then you'd have the ripple, AC ripple displayed up there, in theory. It does bother me slightly that that display is not okay, but it does seem to work. If you put a DC source on it, it just floats around otherwise. But I've also noticed in that mode it reduces the update rate of the display, and it's not a mode I would use very often anyway, so we'll forget all about that and put it onto AC. And what does it do in AC when I select? That's frequency. Oh yeah, it just does pulse width, and pulse width, negative pulse width, and nothing very useful. Nothing very useful. Oh dear, I'm too quick pressing buttons. Right, I got rid of all that, so back in single display mode again. And I think I read in the specifications for this meter that it's got a basic 0.3% accuracy of the reading on DC, plus 10 digits, which is, I don't know, it's not the best, is it? But it's good enough, I suppose. Anyway, what else does it do? It's got min, max, hold. I won't demonstrate. Min, max, and hold to display. And sat mode is to do with I don't know what it's to do with. Oh yeah, set low, set high. Don't really understand that, not really interested in it. Of course you've got your manual ranging, which can be useful sometimes if you don't want to keep switching when it's on auto range. So press and hold goes back to auto, of course. Another nice function is 20 amps on the current range for 15 seconds only. Any more than that and it spontaneously combusts. But that's very useful though for measuring high currents, because my HP meter will only go up to 3 amps. And what's the VICI do? That does 10 amps. So I've got a way of measuring high current briefly if I need to. Does temperature. Never really use that. Ohms mode is interesting. I go into ohms mode just to prove it works. Short the things together, short them together, and of course I can roll that out to get more accuracy at low ohms readings. And it also gives you the what your original reading was, which is quite clever, isn't it? So we'll get rid of that. But if I did select again, I've got bleeper, fine, and select again, I'm in high ohms mode now. Now, as far as I can work out, when it settles, you can measure into the gigaohm range with this. In fact, one demonstration I can do, because it's fairly humid in this garage and the wood will pick up the humidity and absorb it. If I try my probes on the wooden bench, I'm getting 27 megohms, and I could probably move them apart and go even higher. Let's go right down to the end of the bench. Yeah, not much lower, not much higher, I mean. Okay. I'm not sure how useful that is, and it does seem to take a while to settle down. But, come on. But, even if I just touch one probe, settle down, so it seems to be detecting enough between the insulation of the second probe. Well, it isn't now, but I thought it was, but I think it's just a bit of a... Anyway, I haven't got any high value resistors to test, so I can't really test it on that mode. I think the biggest one I've got is 10 megohm, so we'll forget that rubbish. So let's go back to normal auto ranging, and we've got diode mode, and I think it bleeps at the same time. Quite good that it has a 3 volt source. Could have been better, considering it's got a 9 volt power supply in it. Then you would have been able to test some Zeners. But bleep is pretty hideous, but whatever. And capacitance. And what have we got? We've got 17 picofarads, so I think that means. If I bring the cables together, that should increase to 25. And again, of course, you can roll that out to nothing. And then touching 2 probes with my hands, well, the 2 insulated probes, brings it up, of course, because of the increased capacitance. So that's basically what it does. And did I say it's an 80,000 count meter? And if I bring in the other meter here, which is the EEV blog meter, which I'm going to attempt to compare it with. This is a 60,000 count meter. Let's put it on. basically you've got the same resolution until you get to 60,000. Where's the light gone? That's it. So basically you have the same resolution between the 2 meters until you get to 60,000 on this one, but this one will still keep going till it gets to 80,000. So that's quite a good function, I guess. So I think the next thing to do with it is, and it's got a 3 amp current range as well with a fuse in it. Nothing much to see around the back, and in fact the box is almost empty. You wouldn't believe it. You've got a little power supply up that end, main socket power supply, that provides regulated 9 volts, and then the whole of the meter is in this front panel, in this depth here. So absolutely nothing else in the box apart from my bit of circuitry to make the light up when you turn it on. So I think really the thing to do is to just do an accuracy comparison between the what I think is a decent high quality meter and something a bit lower in the evolutionary scale, as it were. So we'll do a test on DC volts and see what we get. So what I've done is I've connected both meters in parallel to this very basic microonter power supply, the first power supply I ever owned, probably over 40 years ago, and I refurbished it recently. But it doesn't need to be a special power supply to do meter comparisons. So now if we go over here, we look at the 2 meters, and by the way, I think this is, I'm sure this is 0.3% accuracy on DC, and I'm pretty sure this is 0.03% accuracy on DC. So an order of magnitude better on the EV blog meter. So what have we got? We've got 10920 on the VC and 10924. So they're not too much out, are they? If we assume this is the most accurate meter, then this one is only a few microvolts out. I think that's microvolts out. Yes, on a 1 volt signal, obviously. But if we increase the voltage a bit, and we go up to, we'll go up to 5, just for something to do. 5.3, 5.3503, 3.349. Again, a little bit of inaccuracy, but it's good enough for what it is. Now what happens if we go up above 6 volts? And yeah, the EV blog meter is a 60 count, although it does go above that, it seems. So a little bit higher there, and eventually it's switching to a lower range, or a lower, so you've less resolution now on this meter than you have on this meter, which hasn't reached its 80,000 count. So I can continue up to 8 volts, and again it had a slight overlap there, but it's makes an annoying noise as well when it changes ranges, which I hate. But so now we're both on the same resolution, but this just has a bit of a higher count. So that's quite good. and we'll just check it at the 10 volts, see what it says at 10 volts. See what they both say at 10 volts. Now, because we got less resolution, I don't expect to see much difference between the two, and that is the case, it seems. 2 or 3 millivolts difference. So that is really the end of that test. We could test it on current, and as this power supply's got a fixed current of 1 amp, I think I'll just test it on 1 amp. So I'm now daisy chaining the power supply with 2 meters and on the amps range. I've had to plug into that amp, the 20 amp on that one, and also the 10 amp range on the EV bulb meter, and it's a bit hard to do a comparison because I think the power supply is warming up and changing, but they seem fairly close. That's all I can say about it. And I expect the power supply will be getting quite hot soon, but no, that's alright, it works, that's the main thing. So that was a fairly good test, I think, on current. I could do the lower current ranges, but I don't see much point. I'm not doing a full review of this meter. It's just to see how it performs compared to a much more expensive meter. So I'll turn my power supply off. I think I could do some resistor measurements, see what they come out at. Oh, by the way, the other things this will do, it will it will do temperature. Did I say that earlier? Hertz. So it's got a frequency counter built in, but it's very limited in its frequency range, and the resolution isn't great as you would have on a decent proper frequency counter. It can also, believe it or not, output a square wave on the probe terminals. I have absolutely no use whatsoever for that, and the frequencies it puts out are most bizarre. It starts at 606 Hertz, and then it's something like 1200 Hertz and so on, doubling each time, I think. So fairly pointless and useless. Well, I guess if you just wanted to see a square wave for some purpose, then it might be useful. Anyway, resistor checks I think are next. Okay, well, the first resistor I'm going to do is I think it's a 15 ohm. I couldn't find a 10 ohm. 15.22. Alright, on the other meter. .96, bit of difference there then. Okay, 100 ohms. 100.23, and the other meter 100.17, only a very slight difference. It's what you'd expect, I suppose. And what have we got next? Everyone's favourite, 1K. $9,885. $9,878. Yeah, bit difference, but I'm assuming this is the more accurate one, which I think it must be. And what we got here, another favourite, 10K. .82, warming up. I wonder if it's my fingers warming the resistor up. 9.856, call it 9.856, 10.035, but getting a bit more inaccurate, I'd say. 100k. Again, it's going up. 99.8. I think it's my hands warming the resistor up, so it's a bit pointless. Yeah, it's about the same. The highest value I could find, I try not to touch these resistors with my fingers when I'm probing them. This is a 10 megaohm resistor. Now that is interesting. 8.9 megaohm. I've got bad contacts. It doesn't really. Okay, that's getting more like it. Still drifts a bit, doesn't it? But these are fairly old and not particularly high quality resistors. .8 meg, call it 9.8 meg. Back on this one again. I don't know why it's doing that. Okay, I think I've got bad contact now by twisting the wires around the resistor. So what happens if I go into select high ohms? Yeah, it does get there eventually. It's a bit slow to respond though. Yeah, I don't like the fact that it drifts down from a higher value. It takes a while to settle. I think we can call that 11.008, and then I move the leads over to the other meter. .11.08 did I say? That's 11.04 and no 2. I can't see. Oh well, they're near enough, aren't they? I mean, I'm not expecting miracles from this thing. So, I think that's the end of the resisting test. I did a current test, so I did a basic current test, didn't I, at 1 amp. I'll put my leads back where they belong. Otherwise, my nice EV blog leads will be in the wrong meter. So that's basically a comparison between the two meters, which I believe this one being the more accurate. So that I think this does fairly well, certainly for the price it was. You're not going to expect miracles at 100 quid, are you? But God, when I think back to when I got my first handheld digital multimeter, it must be 40 years ago. Excuse me. Must be 40 years ago, and I think it cost me about £30, and I bought it as a kit, and it was 3.5 digits, and I was just over the moon to have a digital multimeter that I'd built myself, which was so basic. It had no auto ranging, just free range on voltage, and again free ranges, switchable ranges on resistance, and I think an AC/DC switch for the voltage range. Yeah, I don't think it even had a continuity tester in it in those days. This was just about as basic as you could get, and but it was the first one I'd ever had, so it was a miracle to me, having used analog meters up till then. And if I'd had something like that, this thing here, which probably would have been roughly this equivalent same price, it would just blow my mind. But that's the way technology's gone. That's the bin man outside. That's the way technology's gone. Things have got so much cheaper in real terms. Before I finish, because I think it's enough of this now, I might just show you how I made the light come on, rather than having to press the button every time you turn it on. Okay, this is my CMOS cookbook by Don Lancaster. Very good book if you want to know everything there is to know about the CMOS range of logic chips. So if I go to this page, this is for the... No, I don't want that one. No, next one. Okay, this is a quad bilateral switch, 4066, and what you've got in this package is you've got 4 switches, solid state switches if you like, with control lines that turn them on or off, logic level control lines, and they're very useful for routing signals through. You can turn a signal on and off with a logic level on there, and they can also be used in the application I'm using them now, because I've just got the 2 switch contacts connected across the terminals on the back of the button that does the light, so I can control the turning the light on by putting a high signal on pin 13. And these things are not perfect. They have a resistance when you turn them on, and which will vary according to the voltage you run the chip on. If you run it on 3 volts, then you get a higher resistance on the switch, and if you run it on 18 volts maximum, you get a lot lower voltage. But I have parallel switches in the past to get a lowest resistance. That's possible when they're turned on, and you can use them in theory to route audio signals, but in that case you'd have to use a positive and a negative supply on your chip, say plus or minus 5. Otherwise, because you're effectively routing a audio signal which is going positive and negative. So that's what I've used in this circuit to turn the light on when I turn the power on. And this is the basic circuit. We've got, I haven't drawn all the switches in the chip. I've got your 4066, and I'm using switch contacts 1 and 2, and they are interchangeable. It doesn't matter which way round you use them. And in this case I just want this to go low resistance, and it doesn't have to be a really low resistance, because those buttons are normally controlled by a carbon rubber, which is going to have a few hundred ohms resistance anyway, so that's not important how low a resistance this switch is. And we're running it on 9 volts, and I think I measured about 300 or 400 ohms when the switch is turned on. So what I do is, when the power is applied, you get 9 volts out of the power supply, but on the control point of the switch, which turns on the switch, I've got a capacitor which is slowly charging up via a 120k, and I think the delay time before this gets to the threshold of turn on is around 1 second. So it allows the meter to boot up before switching this switch on. Otherwise, if you held your finger on the switch normally and tried to boot it up, it wouldn't turn on. But once that switch is turned on, I would have thought, because you've got a constant connection there, if you like, on the front panel switch contacts for the light, that it would have screwed up the rest of the keyboard. But no, it doesn't. So that must be an independent line into the microprocessor or whatever controls it. So this circuit is working perfectly, really. Every time I turn on the meter, again I'll show you, it does that and turns it on. So there you go. I suppose I could take it apart, not only to show you the acres of space in there, but to show you my little circuit, which looks really hideous, but I don't really mind because it just works. It's dead bug style. I could take it apart, I suppose. Okay, that's what it looks like inside. As I said, there's not a lot in here really. That's your main power supply, which supplies via a 7809 9 volts to the front panel, and then presumably it does other things in the front panel to get different voltages. As you can see on the front you've got absolutely everything. What that white thing is, that's interesting. White thing. Don't know, might be a thermometer, temperature sensor. And yeah, not a lot to see in there, is there? It's amazing they've got everything on the front panel. That's just a fuse for the amps range, and I believe there's a high value fuse for the high value amps range. And that's your shunt, of course, current shunt. But mains transformer, nicely set at an angle. That's very nice of them to do that. What's that switch do? I bet that's the voltage switch. Yes, it is the voltage switch. But down to my little circuit, which I was just showing you. I know it looks fairly horrible, but that's what it is. It's the 4066 with its legs in the air, and the timing capacitor and the timing resistor connected across the various pins, and some very thin wires which go off to the light switch on the front panel, and power wires going to the 9 volts from the power supply. So that's it really. I'm quite pleased with that, being able to make it do that. Come on, the light come on. So Now I'm going to put the bloody thing back together and struggle with that stupid tilting bail again. Okay, well that's the end of the video, and fairly nice meter. I think they're still available, and it will be used out here as I said. So bye for now.